Next question we have here statement one we have. So if you see the options carefully, everyone. Direction of velocity vector, direction of velocity vector remains unchanged through the Fourier systemic change. If you change the coordinate system, direction of velocity vector will be unchanged. This is a direction of velocity vector. Statement one is does not depend on coordinate system. Next is the direction of real vector is independent of coordinate system. So what is the answer? So obviously, okay, both statement is correct. Both statement is correct. It does not depend on coordinate system. Real vector does not depend on coordinate system. Okay, real vector does not depend on coordinate system. Two forces this and this acting at a point. The resultant can be this. Two vectors acting at the point. The resultant have values between p minus q to p plus q. So obviously the value of maximum value is p plus q, minimum value is p minus q. Maximum value is p plus q, minimum value is p minus q. Maximum value can be p plus q, minimum value can be p minus q. If you see 3, so 7 minus 5 is what? This is minimum value can be what? 7 minus 5. So minimum value can be 2 and maximum value can be 7 plus 5, that is can be 12. So here is minimum value can be resultant can be 3. Okay. So if you see the resultant value, is it okay in between? So both are correct and student is correct. Okay. A cross B is B cross it is wrong. Cross product operators that do not obey. Okay. Commutative properties. If you change that, it will change. If you change the order, it will change. Okay. So second is correct. Correct. Next one is every component of null vector is 0. Every component null vector is 0. Origin and terminus of null vectors are the same point. Terminals, it's not terminal. Means terminals of null vectors are same points. So every component of null vectors need not be 0. It does not depend. But yeah, origin and terminals of null vectors are the same point. Next, A cross B equals to C, where C is a vector. Normal to both A and B. Direction of cross product obey right hand thumb rule. Yeah, always normal to A plus B, A cross B, obviously. But C is a vector, so normal to A cross B, obviously. Vector C will be always normal to A cross B, okay? And direction of cross product obey always right hand thumb rule. This is also okay. A cross B equals to C, and this. Both are correct. Both are correct. Please see, it's not correct explanation because A cross B equals to C. C is the vector normal to both A and B. Let's move to the right hand thumb rule. So basically, if you see cross product to vector also, you can find out by right hand rule. So you can say this is also correct. No issue with it. Next, vector sum of three forces can be 0. Yes, minimum number of unequal coplanar. Unequal coplanar force required to keep a point at equilibrium is 3. So answer is second is true. Vector sum of three forces can be 0. If you take three forces, so a vector sum of three forces can be 0. Vector sum of three forces can be 0. If forces are non-equal, okay, not equal, okay, so you should mention here, okay, not equal, okay, then we can go with it. Otherwise, we will go with this. Okay, next question. Two vectors of equal magnitude cannot keep the point of action in the state of equilibrium, and two vectors may keep the point of action in the state of equilibrium. Two vectors of equal magnitude cannot keep the point of action in the state of equilibrium, and two vectors may keep the point of action. See, if you are applying two vectors, okay, if you are applying two vectors, but their magnitude is same. Okay, their magnitude is same. So obviously you can keep in equilibrium. You can maintain the point of equilibrium. Okay, you can maintain the point of equilibrium. No issue in it. Okay, but magnitude should be equal. Okay, magnitude should be equal. Then only you can mention the point of equilibrium. Okay. Next question you have a vector is described by this. So ay is a scalar. Projection of vector is a scalar. Projection. If you take projections, what you take? Okay. Dot product. Yes or no? This is correct. Next. A dot b plus c is a scalar. So a dot b plus a dot c and dot product of two vector is a scalar. So here both is correct. No issue in it. Okay. See if you don't understand this one, so you can extend this. So this is a dot b plus c. Okay. So you can extend this like this: a dot b plus a dot c. You see a dot b plus a dot c, so it is a scalar. No issue in it. Dot product through vector is a scalar. Okay, no issue in it. Next, we are moving for next question. A dot b cross c does not exist. A scalar and a vector cannot have dot or cross product. A scalar and a vector cannot have dot or a scalar and a vector. If you take a scalar and vector, so how you can take cross product? Okay, a dot b is a scalar product and cross c does not exist. Correct. Next. The resultant of P and Q makes the angle alpha and beta with P and Q respectively. P is greater than Q beta. See, P and Q makes angle alpha and beta. Okay, yeah. It goes reverse. I already explained you. Resultant is always closer to the vector of larger magnitude. हाँ सही है. तो दोनों सही हो जाएगा. So you can go with option number 1. Next question we are going for. This is 1 by root 2 I plus 1 by root 2 in non vector. Component vector of unit vector need not be unit vector. Okay, component vector often if you take component, so their component need not be okay unit vector, and this is a unit vector. Okay, this 1 by root 2. If you solve it, how to check it unit vector? Take magnitude. How to check this unit vector? Check magnitude. Square root of 1 by root 2 का square plus 1 by root 2 का square. If you say solve it, it will be what? 1 by 2 plus 1 by 2, 1 by 2 plus 1 by 2, 1 by 2 plus 1 by 2. So it will come 1. Square root of 1 is 1. Okay. So you can say this unit vector. Okay. Next question we are moving for. I plus a is not a unit vector. The addition of unit vectors never give unit vector. So obviously, if you check I plus addition of unit vector, it can give unit vector, but here I plus a is not a unit vector. Okay, here not a unit vector, but can give unit vector. Okay, addition of unit vector can give unit vector. Next question we are moving with. The torque is pseudo vector. The cross product of two vectors. Cross product to polar vector is pseudo vectors. Okay, cross product to polar vector is pseudo vectors. So here both are correct. If you see, their last questions both are correct. Torque is pseudo vector, and cross product to polar vector is a pseudo vector. Okay, it's not an explanation. Next question we are moving with. When a vector is rotated, its magnitude remains constant. Rotated, you are rotating. Magnitude of vector is independent of coordinate system. So both is correct and correct explanation as well. Next question we are moving with. If a plus b plus c is 0, then a cross b equals to b plus b cross c equals to c cross a. So vector sum of three vectors can never be 0. Vector sum of three vectors can never be 0. Vector sum of three vectors. Okay, so see if here a plus b plus c is 0. And so if you take three vectors, you can do okay. The sum of three vectors can be 0. Triangle of vector addition. Okay. Next question. If A cross B equals to C cross B, then C must be equal to A. इसको ध्यान से देखो, सी हियर, इफ हियर A cross B C cross B, so C definitely A will be C, A will be equals to C, and the magnitude of cross product to vectors depends upon the angle between them. Okay, C must be, okay, C must be, no, C must be no, क्योंकि वो if you mention the angle, because it depends on angle as well, okay, depends on angle as well, okay. So first is false, second is true. Next question. Projection of this on y-axis 3 unit. Projection of A along y-axis A dot J. Okay, so projection of A along y-axis is A. Projection of A along y-axis A dot J, and on the y-axis 3 unit. Okay, projection of this on the y unit 3 unit. So if you see this projection along y is 3, means magnitude along y is 3, and magnitude along axis on z is minus kappa or minus z is plus kappa. But this is not the projections, okay. So this is false. If you see projection of A along y-axis A dot J, okay. Next, we are moving with sum of two unit vector is always or also a unit vector. Their magnitude difference is √3. Resultant of two vectors, we use parallelogram law to find resultant. Parallelogram law, we can do resultant by parallelogram law, and sum of two unit vector is also a unit vector. Then magnitude of the difference is √3. Not making any sense. Next question, the division of a vector by another vector is not defined. The division of vector by a direction is not possible. Division of a vector by another vector is not defined. Division of a vector by another vector is not defined. And the division of vector by direction is not possible. Division of a vector by a direction. See, if you divide any vector by its magnitude, you get the direction. So statement 2 is correct. Division of any vector is not possible, and division of vector by another vector is not possible. This is also correct. A plus B equals to A minus B. A cross B equals to A dot B. This, and this side we have angle here. You put the angle. If you see carefully, A plus B, A minus B, this is will goes to 90 degree. A cross B equals to A minus B, this will go only 145 degree. A dot B JB cos theta by 2. So this is what, 60 degree, and A cross BAB by 2 30 degree. So what answer will come? You can match the answers, and this will come like this. We'll do this question now. Okay. The answer key will come to next. This I dot, and you can basics, you can solve it all, you will get the values. You can solve by yourselves. It's basics of okay vectors. You can solve it. Once you solve, you will get the values like this. So answer will come 3. The next question we have. A minus B equals C, A minus B equals A plus B equals A plus this. Again, you can solve it. You will get the values. These questions. Next, work, power, linear velocity, torque. So see, you can do this question again. See here. Work is what? F dot S. Power is what? F dot V. Linear velocity is what? Omega cross R. And torque is what? R cross F. So you should know all this. So So thank you.